Hey everyone, welcome to day 13. Today is March 15th and we'll learn about storage in Linux. To start, we'll talk about disk partitions. What it is imagine you have a laptop with 1 terabyte of storage. What you can do with it is you can split it into like as many parts as you want. Let's say you want to distribute it. Let's say you want to use your computer for like gaming and then also video making. You can split it 50-50, 500 gigabytes to gaming and 500 to videos and stuff like that. So first of all, we'll talk about block devices. We've gone through this before. This is just a brief reminder since we already learned this in the file type section, right? So pretty much what it is a file type under the /dev directory, and it represents like a hardware component used for data storage, such as a SSD. And once again, the command list block will show you all the block devices in the system. And there's an alternative command right here, but mainly if you take a look at that, you'll see that there's 3 partitions, and we can see what sizes they are and where they're located. So in the above list block output, the device SDA represents the entire disk, right? So this right here, and SDA1 through SDA3 indicate the individual partitions, right? So as you see, SDA1 has the least, and then SDA2 has the most, and then SDA3 has the second most. And you can see there's a major number here. Major number, in this case, is 8, which just identifies a type of block device. And in this case, and the minor numbers differentiate among the individuals. So, like as you can see, they're all the same type of block device. So, in order to differentiate, the minor number has to be different. And now, if we take a look, right, we'll see that SDA3 is the root because of the mounted. SDA2 is in the media directory, and then SDA1 is in the boot. Another useful command is fdisk. It not only lists the partition table, but it lets you create or delete, which is very useful, right? And now there are 3 primary types of disk partitions. The first one's primary partitions. It's mostly used for booting an operating system. And we have extended partition, which act as a container, so it can't be used directly. And then we have logical partition, and it's created within an extended partition to bypass the four primary partition limitation. And then a partition table pretty much just defines how the partitions are organized on disk. And here we have an example of an MBAR partitioning scheme, which permits only 4 partitions and limits disk size to 2 terabytes. And in contrast, GPT supports an almost unlimited number of partitions, which is much better, so it's more commonly used. And so since it's more commonly used, we'll use an example of creating a new partition with it. So using the command gdisk, right here, we can create a new partition. And within the gdisk interface, you can enter a question mark to see the available commands. And to add a new partition, just press N and follow the interactive prompts. And after you sort out everything, you press W to confirm and make it. And you can verify it with lsblock or fdisk with the option L. And afterwards, after this partition, we've got file systems. So to make a disk usable in Linux, we need to create file systems. We need it to read and write data. The extended file system family, which is ext2, ext3, and ext4. So they all have different rules to them, I guess. So both extended 2 and extended 3 file systems support only a max file size of 2 terabytes and a maximum volume size of 4 terabytes. And although they store data pretty efficiently, extended 2 may experience long boot times after an unclean shutdown, and what that means is just shutting down, like having like something else shut down, such as power outage. Whereas Extended Free adds journaling features that enables a faster system startup when such event occurs. And Extended 4 is just better than the other two, and so it's the most popular one right now, as it supports files up to 16 terabytes, and its maximum volume size can go as large as 1 exabyte, which is, I believe 1 billion gigabytes. And additionally, Extended 4 and Free offers backward compatibility, which is a file system, which means a file system created with Extended 4 can be mounted as Extended 2 or Free, whereas Extended Free can be with 2. So like, that's what it means. And so how do we create and mount an Extended 4 file system? So an example, we are doing it on /dev/sdb1. So we'll use the mkfs.extended4 command to format the device. And then next we create a mount point directory and then mount the file system. So running this command, right, and then run make directory and then mount it. And you confirm everything is in order with grep mount pipe grep. And then, another useful command is the block ID to print a universal unique identifier for a device. So basically, if you write in block ID, it will show you what type of block device it is, which is very useful. And the project I'm following is by Akin Tunero, and it's a 30-day project. And day one is really simple, which is setting up. So I followed along and managed to set everything up. So now what I want to say is my directory, right, which is done. Touch file, make the file. Yeah, list it, ls, and then print. So there you go. So pretty simple. That's all for today. Thanks for watching. See you guys tomorrow.